Okay, here's how this is going to work, right? So, spawn in on a platform in a chamber. There can be between 1 to 3 of these chambers. If there are 3, you get one on this side and one on this side, and then they'll be connected by level. If there's only 1, or less than 3, then you're going to get generation around there. It'll be a whole mix of generation and chambers. The chambers are where sort of the majority of the actual puzzle solving happens. And you do this by changing water level, and this will raise and lower blocks that can open up doors or allow you to traverse from one door or another, or if the water level's too low, you won't be able to get to certain doors, stuff like that. Now, there will also be at least one tower, and the tower is where the water goes. So inside the tower, there'll be like a piston system that pushes up, and that sucks the water up underneath, so the water level will be right underneath the piston. It's not a very realistic system, but it's the best for the sort of the game idea. All right, so that means as water outside goes down, the water level inside the tower goes up. Now, from the tower, there can also be tubes, which connect to other towers or other parts of the level. So it can be one there. And this is how the water comes in and out. So that's a bit inaccurate. It would be more like this for the water being sucked in. And then when the water is pushed out, it will go down through the tube and fill the level that way. Now, the water level outside of the tower will be global. So we don't have to worry about specific physics for the tubes, just making sure that, the whole level has a water level at that height. Now, another thing the tubes can do is the tubes can connect towers. So there can be multiple towers and the tubes can connect them, and this is where interesting physics stuff starts happening. So let's say we have 2 towers here, and these both work the same way, except one is a pump tower and the other one isn't a pump tower. So this tower here does not pump, but this one does. So let's say we have a tube right at the top there, and that connects them. So that's connecting them. Oh, and also for the sake of physics, all towers will have a little air vent on the top. That's to prevent pressure issues. But I'm not going to bother drawing that because that's not important. So here, this tower can fill up to this level with water without overflowing and water, piling into this tube here, this tower. Right? However, if it goes above that level, this amount of water there, that will get dumped in here and filled up. Now, of course, we don't actually want a situation that's exactly like this, because that means that we're going to have the piston down here if there is a piston. So perhaps we could have it that towers that aren't pump towers and are just reservoir towers like this, they don't have pistons in them, and instead they have the block system outside, and so we can have a different water level within the tower. That is one option. Another option is to just have tubes, connecting tubes, look a little bit more like this. So here now, this will go underneath the piston when the water level comes through, like that. Another thing that we can do is we can actually have it be the opposite way. So we can have a tube that's really low down there, but that's really low down here and really high up here. So what that's going to do is we're going to have water level within the tower sort of leveling out due to pressure, but I don't think it will be exactly the same because this is constructed. So there's a way that pressure is affected by that, and that will have to be calculated for the effect. So this would probably be higher. That would be higher within the tube itself. And so that would also affect when water starts spilling over, because it wouldn't have to be at the same level. There are other configurations as well that are possible. So, for example, you could have two towers connected like this. So now water will fill up this tube and make it impassable at this level. Well, roughly that level, because it would be higher due to pressure differences. However, it's not until it reaches about this level that the water starts actually spilling into the other tower. So there are lots of interesting sort of mechanics that can be worked with the different water levels in the tower. And of course, you can have up to 3, and they can be all in the same chamber, or they can be in different chambers. Honestly, the more options that you give for generation, the better, because it creates more variety. Another thing is there should be sort of surrounded around the chamber or the chambers, there should be sort of 3 separate rooms that control the water level. And the way that this will work needs to be determined in some way. Like perhaps it affects all pumps, or each one corresponds to a singular pump and works in different ways, or the way that they work differs and that's indicated visually, or something like that. Anyways, these need to be kind of traversed to using generation. They're outside of the chambers, and so it requires puzzle solving to access them. However, the most important thing is that all 3 should be accessible from any starting position, so from any starting water level and inner part of inner sort of puzzle, right? You need to be able to access at least one of the stations that will allow you to unlock another one, and that one in turn will allow you to unlock the third one, so that you can cycle between them or have access to multiple at one time, so that the level is actually playable. That is the most important part, is just ensuring that no matter how the level generates, it's always possible to progress. And that's how it works using the sort of the switches that change the water level. And so the idea is you alter the water level within the chambers, that solves a puzzle, and then that eventually opens up one sort of path to the exit or to the goal or whatever that is. So it functions very similarly to the water temple from The Legend of Zelda, except instead of the inner tower matching the water level outside, it will be kind of the inverse of the water level outside. And so that can be interesting. And then also there's the fact that there is the generation